Ahoy, you salty sailors. Time to raise anchor and set sail for your best scrawny life. Arr.
As we approach a stand of pine trees, we note on the ground a group of mushrooms. In the center of the top of the cap, we see a dark umbo surrounded by fine fibrillose scales. Beneath the cap, we see a ring or annulus around the stem of the mushroom, and we notice that the gills, this is of course a gilled mushroom, do not touch the stem, and that they have a brown color, presumably due to the fact that these mature caps produce a brown colored spore. We didn't, however, get enough of the base of the mushroom to determine if the mycelium is spread out and feeding in the pine needles and forest litter, or if it's going down to the root system and associating mycorrhizally with the pine trees. But based on the available information, do we think that these mushrooms belong to the genus A. Amanita, B. Agaricus, or C. Russula? Pause the video now if you need to, because of course the answer is B. Agaricus. These are possibly Agaricus placomyces, which is part of the Agaricus xanthodermus complex we've discussed previously, and would be toxic, producing a gastrointestinal upset if eaten. And why not throw a random plant into our mushroom quiz? This is a deadly poisonous plant. Could it be A. white baneberry, B. poison ivy, or C. poison hemlock? Pause the video now if you need more time. This is, of course, A. white baneberry, a deadly poisonous plant that produces cardiac arrest. There is also, I believe, a version of this plant that has red berries. I'm not sure if it occurs here in Iowa or not. Here are some of those bird nest cup fungi that haven't opened yet. And on the other side of the tree, we see emerging from the ground, presumably associating with the root system of this pine tree, a white pale mushroom that produces a copious white latex when the gills are scratched. And nearby we see some other pale mushrooms. This one doesn't seem to produce that instant flush of white milk. It has a thick pilipilius or cap cuticle and an acrid, somewhat disgusting smell. So which, if any, of these mushrooms are the same genus and species? Pause the video now if you need more time, because A and C, of course, are in the genus Lactifluus, while B is in the genus Russula. Of course, all three of these are in the family Russulaceae, which we will be visiting off and on throughout the video. Here are some genus Russula mushrooms that are a bit odd. This one with a very short stem producing a white spore dust on the ground. This pinkish capped one, note how thick and rubbery the cap cuticle is, the pilipilius, almost like some sort of silicone. Meanwhile, nearby, we see a great red oak has fallen, quite a bit of dieback in the crown of the tree, perhaps a fungal pathogen was involved, and nearby we see emerging from the ground perhaps Amanita flavorubescens, and next to that, another mushroom, a strange mushroom. Here are some more of them. And you'll notice underneath the cap, rather than the typical radial gills, we see a sponge-like surface of many tiny pores. What family has this strange sort of sponge-like hymeneum? Is it A, family Gomphidaceae, which contains some mushrooms that are parasitic upon other fungi? Is it B, family Hygrophoropsidaceae, those that resemble genus Hygrophorus? Or is it C, family Boletaceae? This, of course, is an easy one that you should know by now. The answer is C, boletes. These are bolete mushrooms with that sponge-like hymeneum. But now for a much harder question. Are the mushrooms seen on the left the same genus and species as the mushrooms seen on the right? Or are they perhaps different species or even different genera? We note that both have a yellow-colored pore surface underneath the cap, and we note that the cap on both mushrooms is reddish in color, although the one on the right seems perhaps a bit more reddish, the one on the left somewhat washed out and pale. We note that the mushroom on the left has a stem texture, which is sort of a continuance of the pore surface. It's that reticulation pattern. But overall, the stem texture of both is fairly faint and indistinct, and we will note that neither mushroom produces much of a staining reaction when the flesh is exposed to oxygen in the air. So what do you think? Are they the same? I am not certain. I think the mushrooms on the left belong to the genus Xerocomus, perhaps Xerocomus ferrugineus, which may refer to a rusty color. And the mushrooms on the right, I believe, probably belong to the genus Hortiboletes, the species of which may tend to have a more distinct appearance in the younger stages of growth. But now let's make another comparison. We know that the mushrooms on the left do not produce a staining reaction when exposed to air, and we see that the new mushroom on the right also does not stain when exposed to air. However, the mushroom on the right does not have that reddish color to the cap, and we note that the pore layer is not yellow, as it is the case with the mushroom on the left, and the pore texture, the size of the pores themselves, is much finer and much smaller on the right. And we note that the mushroom on the right doesn't seem to have any stem texture at all. So I would say they are not the same species, and even different genera. The one on the right perhaps belonging to the genus Tylopolus. Quickly now, what mushroom is this? I've mentioned it in many of my mushroom videos. 3, 2, 1. Russula parvovirescens. These saprotrophic mushrooms that are emerging from a fallen log belong to the genus Pluteus. Note that underneath the cap you'll note the pink tint that the gills have. That's because they're producing a pink-colored spore dust. Now we knew the mycelium of those mushrooms to be saprotrophic because they were emerging directly from a fallen log. But much of what we're observing here emerges from the ground, where it's more difficult to tell the nature of the substrate. These mushrooms, for instance, belong to the family Inocebaceae, the fiber caps. Note that central umbo and the tendency of the cap to split into fibers. These are all considered ectomycorrhizal. That is to say, they get along by forming mutually beneficial partnerships with some of the surrounding trees. The fungal mycelium greatly increases the surface area of the tree's root system, allowing it to uptake more nutrients and water, and in return the tree feeds the mycelium with some of the sugar that it produces. So in light of what we've learned about this mushroom, let's consider a second mushroom. You'll notice they appear very similar. Both have a central umbo. Both have a tendency for the cap to split into fibrous materials. Could we assume, therefore, that this mushroom on the right is also ectomycorrhizal? Well, you can probably guess just by the way I've framed the question that it is not. These two mushrooms are not related. They're not in the same genus or even in the same family. On the right, we see Leucoagaricus rubrotinctoides, which is a saprobe. It makes its living by breaking down forest litter, fallen leaves, and woody debris, and so forth. So similar appearance, but different jobs. And returning to the bolete mushrooms, we see a species with a red cap, a yellow pore surface, and the stem or stipe is also yellow at the top and red at the bottom. And there seems to be quite a bit of it around. On this particular hillside, we see some in the distance. They're very large and mature, and they've come up some time ago, and the bugs have completely destroyed them. But we'll see where one cap overlaps the other, that the mushroom produces an olive brown spore dust. And perhaps most crucially, we'll note that the pore layer produces a blue stain when it is crushed or cut, but the flesh of the mushroom either does not stain or stains very little, and the stem of the mushroom tends not to stain. And note that the stem is more or less smooth. It does not have a reticulation pattern or any other sort of texture. So what are we looking at here? Is it A, boletes sensibilis, the sensitive bolete, B, landmau pseudosensibilis, the false sensitive bolete, or C, Beringia bicolor, the two-colored bolete, or could it be D, Xerocomelus dryophilus, the oak-loving bolete? In 3, 2, 1, the answer is, of course, Beringia bicolor. Not a beginner's mushroom due to the sheer number of lookalikes, and one that seemingly associates with a variety of tree types. And here we have a very large bolete mushroom. This is our old friend Tylopolis rubrobrunis. Would have been a great one for the quiz because the appearance changes quite a bit throughout its stages of growth. However, I did not find any of the younger stages. And here we have another bolete mushroom, similar in appearance to the last one, yet different enough that you can probably tell it belongs to a different genus. And yet, which genus could it be? You'll notice that the top of the cap is rough and pitted and cracked. That is a clue. But allow me to draw your attention to the stem of the mushroom. And here you will observe not a reticulation pattern, but a rather rough and scabrous sort of texture nonetheless. In light of that, could these mushrooms belong to the genus A. lexinum, the rough-stemmed boletes, B. hemilexinum, the halfway rough-stemmed boletes, or C. lexinellum, which I believe is a diminutive form in the Latin. It would roughly mean of the small rough-stemmed boletes. In 3, 2, 1, these mushrooms belong to the genus Lexinellum. This is probably, there's a couple of these that look nearly identical, but these are probably Lexinellum rugossiceps, the rugged cap mushroom of the small rough-stemmed boletes. You can sort of understand why science uses the Latin binomials rather than the common names. And here we have a bolete with a pale brown cap, a yellow pore surface underneath. The stem is smooth with just a dash of red color in the middle. And we notice that it also produces a blue stain where it is bruised or cut. Could it be our old friend Caloboletus inedulus, or our other old friend Landmau pseudosensibilis, or could it be Xerocomelus dryophilus? In 3, 2, 1, Of course, it's our old friend boletes inedulus, one of the bitter boletes. The name, I think, is slightly sarcastic. It seems to refer to the fact that it resembles any number of edible boletes, but instead is bitter, toxic, and inedible.